This was a question sent by the seeds falling under inequalities, so we are going to see how we can easily simplify inequalities. First of all, it is solve the inequality below. This is the inequality. Then I'm giving you the hint. So basically, we need basically 3 steps. The first, you create a 0 on the right. Some people create it on the left. It's okay. And then never lose the denominator, and then analyze critical values. Those are basically the steps. Now, we have finished also covering some inequalities. There are also modulus inequalities. We have finished, and they are there in the playlists. So you go to the playlists, and then you list playlists. You list the inequalities. You scroll downwards, you will see inequalities. So I'm just going to add on this. So after doing this, then I have the simple exercise here. You are going to base on this. So the only difference is some figures, and then the letters, and then the sign. My interest was in the sign. You see, this one is greater than or equal to. This one is just greater than. So I'm going to leave this as an exercise for you. So this is an inequality. We go in the first step. The first step we say is to just create a 0 on the right. So this is our right. So to create a 0, I take this sign. So this is going to be now 1 over x plus 1. Now when this one crosses, it comes 2 over x minus 3 greater or equal to. Now this time we have a 0. So this was our first step, create a 0 on the right. Comma, simplify. So we're going to simplify this one, and just cross multiply, and then we simplify. So this would be x minus 3 minus 2 into x plus 1, the whole over x plus 1, x minus 3 greater or equal to 0. So after simplifying here, this is going to be x minus 2x, which is going to give us negative x. This x minus, when you open bracket, get negative 2x. Then it's going to be negative 3 minus 2 times a positive, there we have negative 2. So this negative 3 and this minus 2 shall get negative 5. Now over x plus 1, then x minus 3 greater or equal to 0. Now, you see that I'm not expanding my denominator. Why? Because we are always, after this step, after simplifying, we need the critical values. Now, at this step, some people are tempted to cross multiply. There, that's when step 3 comes in. Never lose a denominator. So you cannot cross multiply here because we need this denominator under the critical value step. So this denominator is always left. Never be tempted to cross multiply. So you always leave the denominator like that. So after putting this side, we simplify. But in mind, we don't lose this denominator. Good enough, the upper thing is linear, and even these two are linear. But instead they are for forming the quadratic expression if you expand. So don't expand, you can leave it there. Then from here, this one, if it was quadratic, we also factorize it in this form. So always the factorizer can easily simplify when you are getting critical values. So how do we get the critical values? So to get critical values, now critical values. So to get the critical values, because we are going to analyze them, what we do, we equate the numerator and the denominator to 0. So here I have negative x minus 5 equaling 0. So from there I can see that my x is going to be negative 5. So this is one of my critical values. The other I equate is to 0, x plus 1 equaling 0. I have x equaling to negative 1. And then lastly, x minus 3 equaling 0. So my x is going to be 3. Now, negative 5, comma, negative 1, and then 3. These are what we call the critical values. So we analyze them. So you get the critical values by equating the numerator and the denominator to 0. As simple as that. So when I equate this to 0, I get this. Equate this to 0, I get this. Equate it to 0, and simplify, I get the value of x. If it's in y, the same idea. Now, from here, after getting the critical values, we arrange them from small to big in ascending order. That's why I started with negative 5, negative 1, then 3. Then after, analyze these critical values. So, you see, I have negative 5, comma, negative 1, and 3. as my critical values. So you analyze below the smallest. So there you are going to be, if you have 3 critical values, you draw a table of 4 columns. If you have 2 critical values, you draw a table of 3 columns, as we are going to see. So because I have 1, 2, 3, so meaning I'm going to analyze in 4 ways. So here I put the x, then here I put the sign, here I'm interested in the sign. So here we are doing what we call analysis of critical values. Analysis of critical values. Okay, so here the idea is very easy. What you do, you put the value of x or the range of x there. Then here you are going to be interested in the sign. Then we draw our table like this. This should be an easier step for you. Now here we are getting the sign of what we use to get our critical values, and the sign of negative x minus 5 over x plus 1, x minus 3. So we are getting the sign of that expression or that function. So the function used to get critical values is the one you always analyze the sign for. So after doing this, you see that now I have I have 3 critical values. So that calls for 4 columns. So I draw columns. But how am I getting these columns? How do I know there are 4 columns? We analyze below the smallest. So you analyze the x values below the smallest. So you get x below negative 5. That is the first column. Then between this and this, so you get between negative 5 less x less negative 1. Then below this, between this and this, then between this and this. So negative 1 less x less 3. Then after that, you analyze above 3. So for x greater than 3. So that's how my 4 columns can be out. So those are the 4 columns I was talking about. Hope you can see them clearly. 1, 2, 3, 4. If they are 5, you are going to create 6. If they are 3, you create 4. If they are 2, you create 3. So always analyze below, between, then above. If I had negative 1 and 3, I would analyze below negative 1, between negative 1 and 3, then above 3. So that's how the 3 columns will come about. So that's always how we do it. So here we had only 3. So that's where the 4 columns are coming from. Now, my task here is, the idea is, if you can press, of course you know how to press this on the calculator, I'm going to show you. Then you analyze for the figure. So this is the idea you have. You see your critical values are from negative 5 to 3. So you can easily draw a simple column here. I mean a simple number line. So you have negative 5, then you have the last as 3. It's positive. But between negative 5 and 3, there is negative 1 somewhere there. So now, you need the values below. So below negative 5, there is below negative 5. So below this, there is negative 6. Then the value of x is now negative 6. So that negative 6 is what we substitute in here. So let us see. So you see the side below, but you take the closest value, but you see there is a negative 7, negative 8, and so on. But we take the closest as much as possible. So the closest to this is negative 6. So you put here negative 6, now we are having negative 6. Now it's the x value that we are using, 5 over negative 6 plus 1 into negative 6 minus 3. What do we do? Now here, we are interested in the sign. So you see up, we are going to be adding a positive 1, because this is going to be positive minus this over. Down we see that we have negative 5. I think we still have negative 5 into negative 9. Right? This is negative 5 and this is negative 9. When we multiply here, we get positive 1 over positive 45. A positive divided by we are interested in the sign. So here our sign is going to be a positive, so we're interested in the sign. So that's how we do it. So here, below negative 5, the sign of this expression is that if you put in any value, we are going to get the value as positive. So I have here my positive. Then you come between negative 5 and negative 1. Between negative 5 and negative 1, you choose any value between. So you can say there's negative 4, there's negative 3, there's negative 2. You choose any. Then you put it here. Then after putting it here, I'm sure you are going to get that. Then you come to between negative 1 and 3. So between negative 1 and 3, which easiest value can you use? Which is the easiest value of x? Between negative 1 and 3. So the value between negative 1 and 3, the easiest to use is a 0, because it's not here, we have a 0. So that's why here I can now use it. So when I put here 0, this will be negative up, will be negative 0, 0. Down will be negative. So this one is going to give me a negative over a negative, which will give me a positive. Then when I put in a value above 3, you see we have 4, 5, 6, and so on. When you put that value here, the value of that x here, I'm going to be adding a negative, I'm sure. Now, how do I know the signs? Now, always put it, if you are in inequalities, specifically inequalities, don't apply this knowledge in circle, in the curve sketching that I'm giving you. If you are in inequalities, if you have here positive, these ones are always going to alternate. Alternate means you come from positive, negative. If this one was negative, then this would be positive, negative, positive. But I'm going to show you how you can easily put this function on a value and then you pump in the values. Okay, let me show you. So, to put it in a calculator, you come here, you open this. Then you open again, because now I'm going to put in my denominator, my numerator. It's negative x. To press that x, you press alpha, then you press this value, then negative 5. Then I cross. I'm dividing with, now here, I'm going to create another, which is x plus a 1. Then I cross, I open again. This is the product down there. Then alpha x minus 3. Then I cross again, then I cross, then I press this curl. Then they're asking me which value of x are you putting. Now, after you have used this method, now you start. The value of x below negative 5. So there, that's what the calculator is asking you. Which value of x are you putting? Now I'm in the first column. Any value below, which is like, so that's why I can now take negative 6. So then I put here negative 6, you see? Then I press equals. I think you see. But here I'm interested in the sign. That's why I'm having there as a positive. Hope you can see it. Then you want to put another one, you press this one. So you press curl. They are asking you which value. Now I need the value between negative 5 and negative 1. Between negative 5 and negative 1, I can take negative 2. Then I press equals. You see it's negative, but I'm interested in the sign, not the value. That's why there I'm having a negative. Now between negative 1 and 3, when I was working I used the 0. But now between negative 1 and 3, I said it is 1. Let me put a 1. I put curl, then I put 1, then I press equals. You see, it's a positive. But the other time I use the 0. So any value you use as long as it's between, but you make sure you use always cross values, giving you the answer. Then above 3, I use the 4, but let me show you here. You press curl again, then you use a value above 3, we can take 5, because the other time I used the 4. You see, it's negative. As you can see there, it's negative. So what does it mean? It means that now. So that's how you can know. That's how you know how these ones are going to alternate. So that's how we use the calculator to put in the values so that it saves you from calculating this one always. Anyway, so now our conclusion is going to be very crucial because it depends on the inequality sign we have. So we base on this step we used to get a critical values to get an conclusion. Now, you see this sign greater or equal to 0, it means I need positive z. Whenever I say greater than 0, it means positive z. But now this one is having a greater than or equal to sign. There is a difference when we have greater than and greater than or equal to when we are getting these values. Now, greater than or equal to, you see, first of all, I need positive. So I need now, first of all, now my solution is going to be, I come where I have positives. I have here positive and I have here positive. So that's the range I'm going to, those are the two ranges I'm going to take. So because this is positive, greater or equal to 0 is positive z. So I come for this. So this positive, the range was this. So x below negative 5, comma, and then this one, negative 1 less x less 3. So those are the two. If it was less, then less means negative. If this inequality was less at this point where we go to critical values, if it was less, then I will now use this and this. But because it's positive, greater or equal to 0, this means that we are interested in positive values. So when you come to positive values, you take the corresponding, okay? So that's why for positive I take this, and then this I take that. Now, this one, if I have greater or equal to, this one is very important. Now, for any value where I have a critical value which is coming from the denominator, I don't put an equal sign. So you see this one is not coming from a denominator, I put now this. This is the concluding part. I'm basing on this. Now, these two are critical values from the denominators. So I can't risk putting here and putting there. Now, if my inequality here was just greater, then my answers would have been those ones. If it was just greater, that is part of equaling 2. But the moment you see it's greater than or equal to, you just, whenever you see any critical values which is coming from the denominator, you don't put an equal sign to. So because this one was from the numerator, that's why I'm putting. So we put this if we have it from the denominator, if that was the critical values which we are from the numerator. So if I had maybe negative 5 less x less negative, say 1, and it was amongst the solutions, then here I will put this, then here I don't put, because this one would have been coming from the denominator. So we only put an equal sign if we have greater than or less than or equal to. Greater than or equal to, less than or equal to. That's what we base on put the equal signs. But also that one depends on the critical values. Don't put any equal to case to any critical value that came from the denominator. We only put them to those which came from the numerator. Why? Because if you put an equal sign here, it means that there is a possibility of this x value equaling to -1. So if I put here -1, I'll be having -1 plus 1 giving me 0, which would create an infinite value. And you know what comes with we have an infinite value or undefined. So that's the reason. If I put here x equaling to 3, it means that there is a possibility of x equaling to 3. When I put here x equaling to 3, 3 minus 3 will be 0. Anything over 0 is infinite or undefined. That's why for critical values from denominator, if we have this, we don't put anything like an equal sign. We put only for those here, even if this is a 0, it's okay. We can divide something 0 by something. Now, if you had this, then your answers would have been this, all of them. So you take the answers directly from here. But if you have the equal sign case, then you have to put in mind, can it be equal to that? So that's the idea. I wish you well. Don't forget to subscribe to the channel. We are going to see another example, of course, a bit different from this in the next lesson. Check out for that. See you.